All right, let's look at this problem called group the people given the group size they belong to. So, all right, let's try to understand what's given to us. So there are a number of people and they are labeled from 0 to n minus 1, and we have to group them into different sizes. And so what it says is group size of 1 equals to 3 means that person 1 will be in a group of size 3. Okay, let's look at this example. So this person 0 will be in a group of size 3, person 1 will be in a group of size 3, person 2 will be in group of size 3. So I can just add all of these three into one group, right? So okay, let's look at these two examples here. The first example is I have 0, 1, 2, 3, 4, 5. These are the persons, and the group size to which they will belong to is 3, 3, right, 3, 3, 3, 1, and 3. So what we can do is we'll create these groups. So first it says I belong to a group of size 3. So that means there will be a group of size 3 like that. And it's mentioned that it is guaranteed there will be at least one valid solution. So we don't have to worry about whether it's not valid or not. So a group of size 3, you add 0. And then this group of size you add 1. And then you also add 2. Now there is another group of size 3 we need. Okay. So, and there you add 3. Then you add 4. 5 comes in a group of size 1. So for 5, you need to create another group. And for 6 comes in a group of size 3. This is the group of size 3 which has a space. So you add it here. Okay, so we get some sense. Let's look at the other one. Let's look at this. Okay, so what is it? What does it say? So it says 0, 1, 2, 3, 4, 5, and the group sizes are 2, 1, 3, 3, 3, 2. So let's start. This is your group's first element is in a group of size 2. Okay, so it will need one more. Other one is a group of size 1, so it can't be in that group. So it's a group of size 1. Other one is a group of size 3, which will have 2, 3, and 4. And then this one is a group of size 5 is in a group of size 2. Group of size 2 is already, there is an empty group of size 2, so you add it here. So the question becomes is how do we keep track? A group of size 2 has space, right? That's the bit that is coming to. So let's look at it in a slightly different way now. So we can maintain like a hash map, right? And where we'll do, so we start with this again. And the first one is a group of size 2. So we create a hash map with key as 2 and value as a group. And in this group, we put 0. Then we add 1 with the key. And the group is what? Okay, so 1 is a size. And but 1 anyways can only contain, 1 can only contain one group, right? So now you don't need this. Like it's exhausted, right? So you can also maintain a final big list, and this you can remove now because this is done. You like its space is full. It can't. A size of 1 can only have one element. So this guy's job is done, and you remove it from here and add it here. Now a group of size 3. Group of size 3 does not exist. So a group of size 3. In this you add 2. Then a group, this 2, 3 needs group of size 3. Group of size 3 exists, so you add it here. Similarly for 4, group of size 3 exists, so you add 4 here. And then at this point, its size is completed, so you remove it and you add this 2, 3, 4 here. And at the end, 5 needs a group of size 2. Group of size 2 exists, so you add 5 here. It's done, so you remove it from here. You add it here, and this guy says bye bye. Okay, let's sort of apply this same logic here. So we say I need a group, 0 says I need a group of size 3. So key is 3, and you create a list. You add 0 into it, then you add 1 into it, then you add 2 into it. Then you say, hey, I am full, so I can remove myself. Add this as one of the groups. And this guy says I am done, so I'll clean this up. Now 3 says I need a group of size 3 because the first group of size 3 is already done and it's been removed. So I take this group of size 3. So 3 of size 3 and another group I create, and in that I'll add 3, then I'll add 4, And then for 5, I'll create a new, okay, sorry, group of size 1, which will have 5. But as you know, 5, like group of size 1 is already exhausted. It can only have one element. So we can simply put it here like that and clean this up. 6 needs a group of size 3 which exists here. So you go 3, 4, 6, and then you can take it from here and add it here, something like that. Let's try to build a code based on this logic. Okay, so what are we saying? We want to return a of list of integers what we want to return. So we'll say call it groups equals to new, and you want to maintain a map where the key is the size and the value is a list of integers. Call it map. Now we go through each element. So I equals to 0, I less than length. What is the size of the group it belongs? Okay, so size is group size is of I. Okay, if the map does not contain a group of this size, then let's add a group of this size, right? So a new empty list should be fair enough. And so we get a list of integer, and this list is what? This is map.getSize. Now in this list, we're going to add I, that is one we add. Okay, and at some point, if list dot size becomes equal to size, that means this list is full, then you can add it into the final result groups, and you can remove it from this map because this is done. So okay, what else can we do here? I think that's it. And at the end, you return groups. This will be the code. Let's run. Okay, submit. And it does work. So what's the time and space complexity here? Well, the time complexity is quite simple. We are going through each uh, size, we go to each element, that's all right. And within this, it's all O of 1. So that is fair. So time complexity is O of n. What is the space complexity? How much maximum space do we need? Well, obviously, a final list that we are returning will have all the elements again added. And here also, what is the maximum size of a map? Well, if all elements like if the group size is 8 and all elements belong to size 8, then this map will have a single key with value of 8. So basically, the space complexity also becomes O of n. So both time and space complexity are O of n. So yeah, that's it.